Mistakes is perfectly fine. In this class, everybody, excluding me, has the luxury of making mistakes, okay? If you make mistakes, perfectly fine. Don't worry about it, okay? We will make mistakes, we'll learn from it, we'll get better. That will be our approach. So, next 5 to 10 minutes, we are going to focus on tables. I'll pick any name randomly, I'll ask few questions and see how comfortable you are with table, how quick and accurate you are with table, okay? So let's start with Dikshita. Dikshita is second class. So my expectation from you guys is that you should be thorough with table up to 12, if not at least 10. Okay? So Dikshita, you can unmute yourself and 8 7 56 7 9 63 9 4
36
8 9
72
12 4
48
11 9
99
Good job. So this is what Dikshita gets. Good job. So I think you know the tables well, but I would still suggest everybody in the class, okay, that whenever you get 2 minutes in your day, just pick up any table and see from beginning to end if you remember everything. And then catch hold of anybody in your family, catch hold of daddy, mommy, sibling, anybody. Say, okay, fine, ask me some questions on table till 12. Let me see if I remember everything. Do that in a playful way, okay? Not like a stress. It's a game. Math that we are learning here is nothing but a game, okay? So pick up say, okay, fine, ask me questions on any table up to 12. Let's see if I remember everything. And if you get stuck anywhere, that's what gives you a clue that, okay, this table I'm forgetting. Let's practice one more time. Okay? Right. So spend 2-3 minutes. That's a request for everybody. Now let's go to Kaushika. 12 5 6 9
54
11 7
77
9 8
72
7 9
63
This is what Kaushika gets. Let's go to Cherry. 7 8 9 8
72
12 7
82
7 8
56
6 9
54
Good job. So same thing. I will not repeat myself. Even if you are a champion, make sure that you are spending 2 minutes of your 2 minutes of your unproductive time for memorizing tables. Okay. Every day, every alternate day, whatever works for you. Okay. But yeah, make sure that you don't lose focus, because if you become a champion with tables, math will become fun. Okay. Or math will remain fun. Okay, let's go to Sagrika. 8 8
64
12 7
84
8 9
72
6 8
48
This is what you get. Let's go to Pranav. So same thing, 2 minutes every day, regardless of what you are getting here in the class. Okay, Pranav. 8 9 12 5 7 7 9 9
81
8 7 This is what you get. Let's go to Myra. 12 7 8 9 7 4 12 9 Good job. So this is what Myra also gets. And again, I'm not trying to give you a thumbs up just because I'm trying to make everybody happy. I'm certainly seeing that you guys know the tables, and I'll not be shy in acknowledging that I have seen kids, even the higher schools, and they don't know tables. You guys are still in middle school and you are very comfortable with the table. That's why I'm giving you a thumbs up, okay? So I'm not trying to make you guys happy. I'm being very honest to what I'm doing. Okay, let's go to B1. 7 9 there. 63. 12 8 there. 9 9 there.
81.
12 7 there. 84. So 5 minutes daily, no doubt. Okay? Every Saturday be ready for this question, because that's a checkpoint that I have in place for each one of you. Let's go to Gitesh. Gitesh, 9 9 there.
81.
12 7 there. 7 8 there. 7 8 there. 8 9 there.
72.
6 9 there.
54.
Okay, good job. So, okay. So, one for V1 also. V1, it's not that V1 did not do it. I just want him to be more accurate and much faster. So, it should be like this. If any of you want to test my knowledge of tables, okay, let's say till 15 or till 18 or till 20, ask any question. I'll tell you what I want from you. Who wants to go ahead? Who wants to ask? Gitesh, go ahead. You have just 1 minute to ask 4 questions.
What? I want to ask.
You want to ask? Go ahead.
19 times
Huh?
19 times 7.
190.
19 times
19 times 7. This one I have to remember. So that's 153.
7. 18. 47.
72.
17 times 7.
51.
14 times 7.
120. 112. 112. Okay.
19.
Yeah. Go ahead. Last question.
19 times
96 104. Okay. So I'll tell you why I was asking you guys to ask questions, right? The reason was, uh, 19 114. Okay, if I said 104, that was wrong. So why I was saying that was, why I was asking you guys to ask the question to me was primarily because I was telling you this is how I want the answers to come from you, like the way I was trying to answer. I got stuck in 2 places. 19 7 I took some time. 19 6 instead of 114 I said 104. Next class I will also memorize table of 19 one more time. Okay? Because that helps you be fast with your maths. Okay? All of us. I will not preach what I don't practice. So if I'm making you guys learn something, I have to make sure that I'm not making mistake there either. Right? So whatever we did with you guys asking me question and I answering them, that was just for a demo purpose to make you guys understand this is the speed at which I'm wanting the answer, and that answer will help you do the math faster. Okay? Alright, so let's move on. So what we have learned today, in the previous class we learned something that was a break from what we were learning class before that. So we had started with geometry, we had learned the property of triangles, quadrilaterals. We had just learned the basic properties of those. And I wanted to move on with, we started with triangles. We looked at triangles, different types of triangles based on sides and angles. Then we learned about the quadrilaterals. We had started with rectangles, squares, then we looked at rhombus, and then we looked at kite also. Only thing we have not covered is trapezium and parallelogram. or we covered parallelogram. What do you guys remember?
Yeah.
Okay, so let's do one thing. Since we have Dikshita also in the class, she was not part of the class where we were covering quadrilaterals. So we'll just cover quadrilaterals from beginning to end. We'll talk about all the properties, and then from next class onwards we'll start looking at the area and perimeter for these shapes, right from triangles all the way till all the quadrilaterals, and then we'll talk about the compound shapes. Yeah. And I will not only tell you guys the formula for the area and perimeter, I will tell you, or I will teach you guys how are those derived also, how that formula was actually formed. Because if I just give you guys formulas and then I ask you to memorize it, you are not learning any concept. You are just memorizing things, and you will forget. The way you memorize, the way you will forget. Okay? All good? So let's start with let's go through all the quadrilaterals. First, do a recap of all the properties of these quadrilaterals, and then if time permits, we can look at the area part of it also, area or perimeter at least, understanding part of it, and then tomorrow onwards we'll start doing some practice. So, when you say quadrilateral, it has two parts, quad and laterals. So quad is, I think it's a Greek word which stands for four sides, or something which is four, which has four things into it. Four sides, that's what it means. If you break this word quadrilateral defines a shape which has four sides to it. Yeah? So here are the things, here are the shapes that we talk about, and let's look at their properties. First quadrilateral that you are seeing is the blackboard itself, the whiteboard itself. It's nothing but a rectangle. Okay? A rectangle is a quadrilateral, meaning a shape, a closed shape with four sides where the opposite sides are equal. Opposite sides are equal and every angle is 90 degrees. So this guy is also the board on which I am teaching you guys. That is also quadrilateral, which has four sides and all the opposite sides are equal and the angles are 90 degrees. That's the first shape, that is rectangle. Okay? Now, the second shape that we talk about in a quadrilateral is called a square. A square is a quadrilateral, meaning a shape with four sides. Everything is a quadrilateral which has four sides. Okay? So square is also a quadrilateral, meaning a shape with four sides where all the sides are same length. All the sides are same length and every angle is 90 degrees. So between a rectangle and a square, if you see, the only difference between these two is, what is common is all the angles are 90 degrees. All the angles are 90 degrees. What is the second thing that is common? The opposite sides are equal. This and this side are also equal. This and this are also equal. But only new thing that comes in play for a square is that all the sides are same length. I mean, opposite sides are same, but the lateral sides are also same. Meaning every side has same length. Yeah. So that's the only difference. Otherwise, a rectangle and a square has all matching properties. Meaning opposite sides will be equal, all angles will be 90 degrees, that holds true here also. But here this side and this side are also equal. Okay? Meaning in square all the four sides are same. So far, any doubt? I'll keep on asking you guys, okay? No doubt, right? Okay. Now the third quadrilateral we talk about is called a rhombus. So rhombus is nothing but a distorted form of a square. Okay. Now look at this guy, this square. What happened? We twisted the square and we squeezed it from both the sides. What happens? Okay, now I'll have to do the same thing that I've done before. So now if you look at this, let's say these are two sides of a square, okay? These are two sides of the square and there are two sides below, okay? So I'm just showing you the two sides. If somebody squeezes from here on near the elbow, right? If somebody applies the force and makes it grow taller, okay? So it was like this, it was flat. Now it has become taller. This shape, if you look at this and this, what happened? Somebody squeezed from this side. Somebody squeezed from this side. These two sides. What happened? This went up, this and this. This is what happened. So this became thinner and taller. Meaning this side's length remains the same. So in case of square, all the four sides are same. In case of rhombus also, the sides will remain the same. They will just get closer to each other. Meaning the angle will not be 90 degree anymore. This is not 90 degree. This is also not 90 degree. This is also not 90 degree. This is also not 90 degree. It just same shape became taller and thinner. That is what is rhombus. So if you have to compare between a rhombus and a square, you always remember this bad style of teaching. Where I said somebody squeezed the square to make a rhombus. Meaning your sides are all the same. The only difference is what is same between these two? The length of the side. All are same. What is different? This has all angle as 90 degree, this doesn't. Everything else is the same. Here, all the angles are not 90 degree because somebody squeezed it, distorted it, made it taller, thinner. This guy has all 90 degrees. That's all you have to remember. One extra characteristic that you want to know, if you have a rhombus, this is called diagonal. The two opposite vertices, if you join them, this is called diagonals. The diagonals of a rhombus cut each other at 90 degrees. That's the only property that you might want to know at this point in time. Okay? Yeah? Alright. So we have looked at rhombus, we have looked at square, we have looked at rectangle so far. Let's look at other shapes. Yes, somebody had a question. No? Okay. So we have looked at rectangle, we have looked at square, we have looked at rhombus. Then other thing, I'm not sure if you guys have got a chance to play with that. That is called a kite. Has anybody in this group kind of had the opportunity of flying a kite?
Yes.
Who did that? Gitesh and Pranav? Oh, Vivan also? Very nice. Sagarika also? Wow. Everybody had a chance to fly a kite. That's good. So here, what is the difference between a kite and other things that we have seen so far? Kite is little different. Everything else that we looked at, where either the opposite sides were same or all the sides were same, here there is no opposite side being same. Okay? Here the two pair of sides, meaning this side and this side are same, this side and this side are same. Okay? And there is no commitment on the angle being 90 degree or anything. The angles are not 90 degree for sure. You would not see a square like kite flying. Okay? It's always two sides shorter and two sides longer at the bottom. Okay? So that's a kite. Okay? Here also another property that you might want to know is the diagonals. The diagonals cross each other at 90 degrees. Okay? And they equally divide themselves. So here, this case and this case, same property. The diagonals, this part and this part same, this part same, and they meet at 90 degrees. Here also the same thing. Okay? Yeah. These are just the properties. Okay? There is no proof for this. This is how these shapes are defined. Okay? Now let's look at the next one called parallelogram. Parallelogram is also a quadrilateral where the opposite sides are same and are parallel. What does it mean? If the opposite sides are parallel, what does it mean?
Straight? No, it means that the sides won't touch even though
They will never ever meet each other, like a railway track, if you guys have seen. The railway tracks never meet. Yeah? The day you see two railway tracks coming closer, you have to report that as a problem because there could be a train accident. Yeah? So, in the parallelogram, the property is the opposite sides are parallel to each other and they are equal to each other. Yes, Gitesh? Okay.
I accidentally was there.
That's okay. So, in a parallelogram, the property that you need to know is a quadrilateral is called a parallelogram when the opposite sides are equal and parallel to each other. Meaning this side and this side are equal and parallel to each other. Meaning if you extend these sides, no matter how far you go, they will never get closer to each other. Meaning the distance between them remains fixed. Whether it's here, here, no matter how far you go, they will meet at infinity. And I don't think I ever had the chance of going all the way till infinity. Neither will you guys get. Yeah? Meaning they don't meet. As simple as that. Now, same thing for this one also. The opposite sides, these two also. So basically the opposite sides, each pair of opposite sides in a parallelogram is equal and parallel to each other. Okay? Does that mean in my rectangle the opposite sides will ever meet? No. In the rectangle or in the square also, the opposite sides will never ever meet because they are also parallelogram. Parallelogram is a generic term, a generic shape which says that I am a parallelogram if my opposite sides are parallel and equal to each other. Here also, rectangle also, the opposite sides are parallel and equal to each other. They also don't meet. So, what it means is, every rectangle is also a parallelogram. So, in the case of square, the opposite sides are equal and parallel to each other. I mean, here all sides are equal. So, opposite sides will be equal by default. The opposite sides are equal and parallel to each other. Meaning, every square is also a parallelogram. Now, you will ask me, if the rhombus is also a parallelogram, I will let you guys find it out, okay? I know the answer. Yep. What is the answer?
Yes.
It's a parallelogram? Okay. Okay. So same thing applies here also. So when in the case of a rhombus, what you're doing is you are applying pressure in a uniform way. And it gets distorted but in a more uniform way, more symmetric way, meaning the opposite sides will still remain parallel. So that's why a rhombus is also a parallelogram, because the opposite sides are same and then they are anyways parallel to each other also. Okay? So you will not deform a square to make a rhombus like this. You will apply pressure, equal pressure on both the sides. That's how this is still symmetric. It is not distorted. You are not making a rhombus like No. Let me see if I can. We are not making a rhombus like this by applying lot of pressure on this side and less pressure on this side. Rhombus doesn't become like this, okay? Rhombus is always like this. That means the sides will remain parallel, okay? Here, if you apply lot of pressure on a square on one side, this is what it will become. This is not a rhombus for sure. Yeah? Alright? So, here, rhombus is also a parallelogram. Now the reverse of the question is every parallelogram a rectangle or a square?
No.
No. It cannot be, because you can have parallelograms where the opposite sides are equal and parallel and the angles are not 90 degrees. Okay? So this is like the big brother. This is a superset. Parallelogram is a superset which covers rectangles, it covers squares, it covers rhombus. So every rhombus, every square, every rectangle will be a parallelogram, but the vice versa will not be true, because there are more shapes inside parallelogram which is not rectangle. Okay? Are you guys okay so far?
Yes.
Okay. Now let's look at one more shape, and then we will go to learn something more, because I know some of you are already getting bored because you have learned this before. So let's go to another shape. What is this called? Trapezoid or trapezium, whatever you like. Yeah? What is the property of this guy?
It has one parallel side.
One pair of parallel sides.
Yeah, one parallel sides.
Or you will say it has only one pair of parallel sides. Because the time you have two pair of parallel sides, it will not remain a trapezoid.
Yeah.
Okay? So, a trapezoid is a quadrilateral which has only one pair of parallel sides. So this side and this side are parallel. And I never ever said that the sides have any other relationship. I did not say that they are equal also. I just said they are parallel. Meaning, if here you can see, this side is much smaller than this side. But they are still parallel to each other. Meaning, you can extend them. Anything that we call as parallel, those are the sides that will never ever meet, no matter how far you extend them. Okay? Any questions so far?
No. No, sir.
Pranav, sit down properly, beta. Okay. All right. No, I will keep on reminding you guys so that here in the classroom, if you see, I am literally sweating. It's so hot. The kids who used to come to the classroom, I'm making the room little better now. I'll get a mist from tomorrow, so that way it will be a little more comfortable here. So you'll not see me sweating as much as I'm sweating today. But yeah, coming back to the point. So we have learned about the property of different shapes in the quadrilaterals, and we had learned about the triangles before. And I know Dikshita might not have attended that class, but I will share the link of that class's video. You can watch it offline and let me know if you have any question. And regardless of whether you are able to understand, not able to understand, you have learned that before or not, we will anyways end up repeating a lot of things again and again, okay? Because in this class, this is for level 2, where we will learn all the concepts from 6th to 8th grade. And trust me, if we keep on doing 8 classes in a month, we will learn all the things maybe 6 to 7 months. So we will have enough time to repeat, revise ourselves, okay? And anyways, kids who are going to 6th grade this year, And in next 6 to 8 months, if they learn all the concepts for 8th grade also, they will get bored, and then we'll start doing practice also. So that way you guys stay ahead of your class always. Okay? That's the goal. Alright. Yep, you're saying something. And also one more thing for you guys to know is I go with my flow of topic, okay? I have my own predefined flow. But once class starts for you guys, if you want certain topic to be covered, say okay, in my school these are things that is going to be taught, or they have taught something which I have not understood. You can ask your parents to send me a WhatsApp message saying, okay, can you teach this particular topic to my kids in this class? So we will do that. We'll learn it for everybody. Okay, we'll teach that. I will teach that in the class, so that you guys can keep pace with what is taught in your school. At the same time, you keep learning for your future SAT exams also. Okay. All right. And one more thing. One more thing is, all the kids. I know many of you are sending assignments to me, and I have been checking that. And thank you for sharing it. But in the class, another thing that is expected from each one of you is you will do your assignment and show it to your parents, saying that this was my assignment, this is what I have done, this is how I have done. So when you try explaining it to them, that is when you will know or get to know whether you have understood the things correctly or not. If you are getting stuck somewhere, if you are not able to explain, that means there is something that you did not learn well. And then that will come to me as a feedback saying, okay, fine. Today, this kid did not understand this concept or was not able to explain the concept to the parents. They will give the feedback to me. I will make sure that I explain that one more time in a better, easier way. Okay? So that is the purpose of you guys showing your assignment to your parents and then sending it to me. Your parents will see, okay, yes, my child has learned something and is able to explain. That will give them a lot of happiness. Okay? They will feel very comfortable that yes, my child is learning something and is able to explain that. And then when you send it to me, that's just more of an affirmation that yes, you finish your homework. Okay, now how much time we have? We still have 25 more minutes. Anybody wants to take a quick bio break, 1 or 2 minutes break, wants to get water, please do so. I'm going to go get some water for myself. We'll be back in 2 minutes and then we'll resume. Okay? Okay, I'm back. So I think everybody is here except Pranav, and Pranav is also here. Everybody is here actually. How about Gitesh? I don't see Gitesh. He should be back. Alright, so now we are going to learn about the area and perimeter. Okay? So in today's class, we'll spend some time to conceptually understand what do we mean by area, what do we mean by perimeter, and then we'll start gradually learning how to find out the area and perimeter for different shapes and objects that we are talking about. Okay? There are some shapes for which I'll be able to explain how to derive the area, the formula for area. There will be some shapes I will not be able to, because those are using very advanced concepts of calculus, and if I try teaching you guys calculus now, I'll be making you guys mad. Okay, so I'll not do that. So most of the concepts or the formulas for area, we will be able to derive it here in the class and explain you, but there will be some that needs more advanced math concepts. That I will not teach you, I'll just tell you the formula. But that will be only a few, okay? Not many. Yeah? And I will teach you guys those formulas, how those are derived. When we get little older, learn little more advanced concepts, and then when we get more comfortable with calculus and everything. Okay, so let's continue. What is your understanding of area? Let's make it more interactive for next 20 minutes. What do you mean by area? And give me very practical answers. Okay, I don't need very loaded answers. Something that you can relate. Yep. Yeah, Gitesh.
The area of the space it takes for like something
Okay.
like
Area is a space that it takes. Okay, I will take it as one option. Okay, what else? Let's see. What is? Yep. Yes, Sherry, go ahead.
area is the
Yep, enough.
area is the space inside the object.
Area is the space inside an object. Okay, I'll take that also as an answer. Let's see what Cherry says. Same thing. Area is the space taken by any object inside it. Okay. How about you, Dikshita? You were saying something.
I think it's area of shapes.
Area of shape. So area is what we are trying to find out. Area of shape. I'm just trying to add more practical flavor to it, saying what is our understanding of area. See, I can teach you guys math in the way of math, but I am not trying to do that. My objective is to teach you math as part of our life, meaning what we see around us. Let's say if I look at this, my phone. What does it look like? It looks like a rectangle. So tomorrow somebody says a rectangle. I know, yeah, I deal with rectangle every day. My phone is a rectangle. My laptop is a rectangle. My A4 sheet is a rectangle. My dining table is a rectangle. Yeah. If somebody, my dry eraser is a rectangle. My whiteboard is a rectangle. Yeah. So this is part of my life. I'm not learning math, I'm using it every day. Yeah? If somebody says circle, yeah, my car's wheels are circles, my steering wheel is a circle, my face is almost like a circle, yeah, my eyeballs are like circle. So there are a lot of things that we can relate to, and that is how we will try learning here. So that's why I was saying, when you say area, what is our understanding of area? Now let's get little more insight into it. This is a triangle, okay? And if I ask you guys, I give you a piece of paper of this size, okay? I will say draw this triangle on this piece of paper. Draw this size of a triangle on this piece of paper. Will you ever be able to do that? No. Because the space or the area taken by this guy is much more than what you have here on this piece of paper. Yeah? So, if let's say somebody here in this group is interested in drawing. I know Myra is certainly interested in drawing. She does a lot of drawing. If I give her this big a piece of paper and say draw the house, draw the picture of our house on this piece of paper, she will not like that idea at all. She will say, my daddy has gone mad and he is asking me to draw this small, draw the house, the big house on this piece of paper which is so tiny. Because she knows that the area needed for drawing that bigger house is much bigger than what I have. So, now with whatever we have seen so far, or whatever we have discussed, area of any shape or any object is the space taken on the surface where you are trying to draw it. Now look at this. This is the board I have. I am drawing a rectangle. Then I am drawing a triangle. Then I am drawing a circle. Then I am drawing a rhombus. Done. If somebody says, draw another trapezium on this board without overlapping with any other shape of this size, can I do it? No. Because the space on the surface that I had is already consumed by this guy, this guy, this guy and this guy. I do not have enough space left for drawing this guy. Yeah? So, in most practical terms, I don't think you have to write the definition of area anywhere, but for our understanding purpose, you can always assume that area of any object or shape is the space taken by that on a given surface. You always measure the area on a surface. You cannot measure the, let's say, if I said that my face looks round like a circle, yeah? Can you find out the area of my face in air? No, you cannot. You have to draw it somewhere on some surface, then calculate the area. Yeah? So area is always against the surface. It's always a surface against which, where you are drawing it, where you are placing it. Let's say if you want to know how much area my feet takes on the floor, you will have to make me stand on the floor and then draw a line around draw a curve around my feet to find out how much space I need to stand up and do the class, right? So area is the space taken by any object on a given surface. So that's what we are seeing here. We have this much area, out of which this much was taken by this guy, this much by this guy, this much by this guy, this much by this guy. That's a very simple thing. Area is the space taken by any object on a surface. Okay? So, if somebody says, draw any diagram or any shape, any object on the surface, or draw anything, what you have to do is, okay, you have to find out, okay, how much area that guy needs and how much space I have on the surface where I'm trying to draw it. Yeah? Let's say during the festivals we do rangolis in front of the house, right? And if you have to make a big rangoli like this, you would certainly need a bigger place. You would not want to do that in the corner of the house where you have only this much tiny space, right? Yeah? So that's the relevance or practicality of the area part. Anything that you are trying to draw on a surface, you have to have enough space, or you have to have understanding of how much space that guy will take. That is my area. Yeah? We have discussed about area enough. I know you guys are getting tired. Yeah? Okay. That is the area. That is a conceptual view of area. Okay? We will talk about the area of different objects one by one. Let's now try understanding what is perimeter. Perimeter. Popcorn chicken, Divan. Okay. Yes, Myra, tell me what is a perimeter? Myra, you want to be louder?
It's the border of the shape.
It's the border of a shape. Okay, I'll take that as an option. How about you, Gitesh? You want to say something?
The border of the shape.
Border of a shape.
Or like a border of
A little louder.
house. A border of the house.
Border. Border of my computer house. Okay, I'm not going that far. I'm saying, okay, what is a perimeter? So, a perimeter, again, we're talking with respect to a particular object. So, the border of the object, that is one definition. Anybody has any other way of representing what is a perimeter? Any practical, silly, stupid, creative example?
It's the line of the shape.
Line of a shape. Can you elaborate that a little bit more?
Like the line surrounding
Line surrounding the shape. Okay, that could be a partially correct answer whenever you're talking about shape with lines. But if you're talking about a shape like a circle, that statement would need to be revisited. Yes? Okay. So, perimeter is the boundary of a shape, length of a boundary, whatever you call it. Now, perimeter, there's no rocket science here, no further thing to be described, but in simple terms, if I have a shape like this, what I need to do is add the entire border from here to here, here to here, here to here. All the four I have to add. That is what becomes my perimeter. If I have a shape like this, what is my perimeter? Start from here, travel all the way, come to the starting point and find out the total length. So perimeter, if you want to imagine or visualize any object that you talk about, perimeter of the object will be like, it's like putting a string from starting point to end point. Take a big rope or a string and align it from here to here. Then align it from here to here, here to here, here to here, to the starting point. And then measure how long the string was. That's your perimeter. Okay? So, let's look at the basic formulas for perimeter, okay? Because there is nothing to prove, there is nothing to find. Perimeter is simply the length of the entire border. So let's try finding out perimeter in the class today, and then we'll go to the area part starting tomorrow, okay? So now, if I say, I have an equilateral triangle with 7 centimeter each. I have an equilateral triangle with 7 centimeter each side. What is the perimeter of this triangle? Can somebody tell me?
21.
21. Why? Because I said equilateral triangle, meaning all my sides are same. And that is why I was emphasizing on the property, right, since beginning. That's why we covered the properties first. So as soon as I say I have an equilateral triangle with each side 7 centimeter, first thing that came to your mind was, oh, it's an equilateral triangle. Meaning this side are all same. This is 7 centimeter, this is 7 centimeter. So my perimeter is length of the entire string that I can lay around the boundary of this. So 7 centimeter, 7 centimeter, 7 centimeter, 21 centimeter. That's it. So property is very important. If I say I have isosceles triangle with the equal sides are 8 centimeter each, and third side is 5 centimeter each. Find out the perimeter of this isosceles triangle. I said I have an isosceles triangle with the equal sides are 8 centimeter in length and the third side is 5 centimeter. Not Gitesh, I want to see what Sherry says this time.
21 centimeters.
How much? 21. Gitesh, is your answer also 21?
Yes.
Okay. Everybody, any doubt? It's an isosceles triangle, meaning two sides are same. This side and this side are same. So this is also 8 centimeter. You add them together, 8 plus 8 plus 5, 21 centimeter. Vivan, what was that? Oh, okay, no, I was just wondering if you got a different answer, okay? Okay, all right. So this is the perimeter part of it for triangles. Now, if somebody gives you a scalene triangle and say this is 12 centimeter, this is 5 centimeter, find out the perimeter of this guy. Will you be able to find it? Gitesh, you have raised your hand. Okay, I'm saying I have a scalene triangle with 5 centimeters one side, 12 centimeters other side. Find out the perimeter of this guy. Who all can find the perimeter of this guy?
Is it
I said this is a scalene triangle. Scalene triangle, and I am giving two sides. Okay, let's say Dikshita. What's your answer, Dikshita?
22.
22? No. I said scalene. Scalene triangle is a triangle where all the three sides are different. Right? So you were not in that class where we were talking about the property of all the triangles. So that's why I'll give you the link of that one. But yeah, the thing is, it's a scalene triangle, meaning all the three sides are different. So if the three sides are different and I am given only two sides, that means the third side is anyways not known to us. And third side is not known, I will not make an attempt. Because perimeter is a simple thing, I don't need a formula. I just have to add the three sides. Since I know only two sides, Divan. Since I know only two sides, I will not be able to find out the perimeter of this guy. Okay? Whoever is asking me that question, saying find out the perimeter, I'll say give me the third side, I'll find you in 2 minutes. Yep. Everybody with me so far?
Yes.
Okay. We have 5 more minutes. Let's look at this is a parallelogram with this side as 8 centimeter, this side as 6 centimeter. Who can find out the perimeter for this one? What is that? Okay. That is one answer. Anybody got the same answer, different answer?
I got 22.
22?
I got
28? Okay.
28. Same.
Same. Anybody got different answer? I'm interested in that. Rashika? You also got 28? Okay. Myra? 28? Pranav? 28? What was your answer, Pranav?
It was 28.
28. So yeah, it seems you guys are all good friends. Everybody is getting same answer. And nothing fancy about it. Perimeter is nothing but the length of all the sides. And just because you guys know the property of parallelogram, that the opposite sides are parallel and equal. So as soon as you know the property, opposite sides are equal, that means you know this side, this is 8 centimeter, then this is 8 centimeter. This is 6 centimeter, this is 6 centimeter. And that is where the property of the shape that we have covered helps you relate it and do it faster. Okay? I can guarantee you guys that till SAT level, nobody will come across any difficult question. We always come across easy questions. We actually make them difficult just by either overthinking about it or making a mistake in a hurry. Okay? So that's why don't do that because that is distracting me. So any sum that we come across, always have to read it, spend some time to analyze it, make your mind how to do it, and then you do it. And that is where my most favorite theory of Tran comes into play. I know many of you have heard it so many times that you are tired of it, so I will not repeat it today. Maybe Dikshita is the only one who doesn't know about it. I will explain it later. Okay? When we have few more students, let's say another 4 students come, I will explain what is Tran. But in summary, it is you have any question that you come across, you have to read, analyze, make your mind, decide how to do it, and then you do it. So that is why when you look at this question, when you look at this, this is a parallelogram, you immediately realize, okay, parallelogram means the opposite sides are same. Opposite sides are same, and then you know how to add them and find it out. Yeah. So we are not talking about Tran today. Okay. Now, if somebody says, gives you this shape, Can somebody find out the perimeter for this one? This is a shape. I don't know what is it called. This has 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So maybe an octagon. And this is 5 centimeter, 8 centimeter, 12 centimeter, 18 centimeter, 5 centimeter, 12 centimeter, and 8 centimeter.
Are they all centimeters?
Yeah,
Okay, then I got 68.
68. 5 plus 8, 13 plus 12, so 25 plus 18, 43 plus 5, 48, 60, 68. Yep, that's the answer.
Same answers.
Same answer. So, see, even if you get a shape like this, somebody says find out the perimeter, the first thing that should come to your mind, do I know the length of all the sides? And if I do, add them together. Only thing that will not help you just by knowing the side is a circle. Once we come to the circle, we'll talk about how to find the perimeter for that. Okay? But for anything which is made of the straight lines or line segments, it's just about knowing all the sides by knowing the property of the shape that you're dealing with, or knowing the individual sides and then just add them together. That's all about the perimeter part of it. So starting tomorrow, we'll start to learn about how to find out the area of different shapes, how the formula for those shapes defined, and then we apply those formulas for doing some sums. That's what we'll start from tomorrow. And that brings us to the end of the class. Any questions?